All right, so we've got our classic unit circle here, and I'm describing the point on the unit circle in terms of this angle. All right, so as I drag this point around, my angle changes, and what this allows me to do is it allows me to describe the height and the x-coordinate, the left and right distance, in terms of sine and cosine of that angle. I've talked about this before. What I want to talk about this time is something called the Pythagorean identity. Right. So hopefully you see my right triangle inside here. If I apply the Pythagorean theorem to this, so by the Pythagorean theorem, I get a squared, so cosine squared, plus sine squared is equal to 1 squared, right? Just leg squared equals the hypotenuse squared. And I can leave off this little 1 squared bit because 1 squared is just 1. And this is it. This is called the Pythagorean identity. Right? It is very simple. Everyone knows it and it's easy to memorize. But it's sine squared plus cosine squared equals 1. And usually that's the way that I'll write it. Yeah. I usually write it without the theta. So I'll just say sine squared plus cosine squared is equal to 1. Means the same thing. It's got the same idea. So in practice, like with your calculator, what it means is that no matter what angle you choose, right, if you do the cosine of that angle, so I'll just do a 25-degree angle here, and if I square it plus the sine of the same angle, delete, all squared, if I add those up, I get 1, right? It doesn't matter whether you're in the first quadrant, second quadrant, third, or fourth, okay? It always comes out to 1. It's a very nice little formula, or identity, that's what they call it. Now, what I want to do is I want to take this and do a little bit of algebraic manipulation, kung fu, whatever you want to call it. If I solve for sine squared, if I take this and just isolate the sine squared, I would have to move this cosine squared over here. So that would be 1 minus cosine squared. Okay, and vice versa, if I solve for cosine squared, I would get cosine squared is equal to 1 minus sine squared. That's nice. It's helpful. I will use this later when we start simplifying trig expressions. But if I take the square root of both sides, okay, so pretend I took the square root here, took the square root there, that's going to leave me with sine of theta is equal to the square root of 1 minus cosine squared. Now there's probably like a plus or minus there, but that's just for like determining quadrants and stuff. And over here on this side, it would be the same thing. It'd be cosine is equal to the square root of 1 minus sine squared. And you can't simplify this further, all right? You can't just write it as 1 minus cosine. It doesn't work like that. But these two identities, well, these 5 identities actually, are very handy. This is the only one you really need to memorize because you could easily get these other ones from it. But these will be helpful because if you know cosine, this is a quick way of figuring out what sine is. Right? We'll do some examples of that here in a bit.